Before I move on to security today, does anybody have any questions on uh, the parts that we went over in protection? So mainly, it's the concept of these domains and access levels to objects, and then the tables that we saw. So I know some of the last part of the table we went a little bit quickly over, but really I recommend looking through the tables and their examples to get the hang of that, because there's a lot of different things that can happen from different combinations of access levels. But the main concept kind of comes together in these access matrix. Okay, so this implements everything we saw with our diagrams and everything, with the domains, with the different objects inside them and how they cross over. So this is an implementation of that. Okay, so if there are no questions on this, then we're going to look at security today, because these two chapters are very interrelated, and like I said before, a lot of times they're discussed together, and these authors simply choose to separate them out. Maybe to add an additional chapter in their book. So, security. Okay. We're going to look at security issues in general, and then when dealing with security, you're often going to do it systematically with a lot of pretty high-level tools and concepts, so that you can, because security is a difficult problem. So we're going to look at the different types of what they're calling threats and problems that can come up that security addresses, and then we'll see the different tools. Some of them listed here. We have like cryptography, user authentication, and then these are kind of security strategies and in different areas. Okay, so we'll take a look at the tools as well as implementing those tools into a complete strategy. Okay, so let's take a look at the threats and attacks. So, and they kind of have a unique definition of security, in that they concentrate on external threats with security. You'll remember from talking about protection that a lot of that was talking about internal problems, right? The idea of two authorized users on a system, sharing resources and not conflicting with each other, not using each other's resources, how to separate those areas. So it was kind of looking at the internal access problems that could happen, and they're separating out into security, focusing a little bit more on the external problems. This may or may not be a good idea to think of them as two separate problems, but the material you have here chooses to look at them as two separate problems. A lot of people in security actually look at them as the same problem. They don't like to state it as such, but the idea is that you trust your internal users just as much as you trust any malicious attacker from the outside. Or you treat everybody the same. Is another approach, but they look at it in two different areas in this material. Okay, intruders, they're calling them crackers, system crackers. Okay, attempt to breach security. They attempt to overcome these security practices and utilize resources in an unauthorized manner. So the idea behind external attackers is they want to come in and use your resources. So whether that's running programs, whether that is defacing web pages, whether that's stealing corporate data, whatever. But they want to come in and either take data or utilize resources. Okay, so some terminology. Threat is a potential security violation, and that's usually what we deal with when designing systems. We think of the threats. What are the potential unauthorized uses of our systems? And then attack is an actual attempt to breach security. So an attack is a threat realized. Okay, attacks can be accidental or malicious. Again, a lot of this is just really a matter of whether you look at these things as separate or not. Easier to protect against accidental than malicious misuse. This last bullet, and that is fairly that's a very important issue. The idea of the difference between a malicious attack and just an error or accidental attack. Security should be approached assuming that all of the worst things that could happen with your computer system will happen. Okay. So a lot of it is not what you would do or what might happen. You assume that everything bad that could happen will happen, and a good security system will still stand up to this. Okay, so you don't want to depend on luck. You don't want to depend on them not knowing something about how your system's set up or anything like that. Okay. So, security violations. We have 5 different categories up here. The first 3 are the kind of classic violations of security. Remembered by their 3 initials, CIA. Okay, confidentiality, integrity, and availability. Those are kind of the big 3 of security. Okay, theft of service and denial of service. These are kind of broken out separately. A lot of them are associated with availability. Okay. Or integrity. They're different combinations, but they are very popular, especially denial of service. Kind of a newer concept in security is the idea of system vandalization. So some people will do denial of service where they make it so your system doesn't work just for fun. It's like they don't get anything out of it or anything like that necessarily, but some of them will knock out websites or databases or whatever just because they can. All right, so denial of service is actually a very common, such a common attack and such a kind of unique set of circumstances that it's broken out usually into a separate category. But the first 3 are really, if you understand those very well, you pretty much have a good handle on any kind of security violation. And they are very descriptive. So what do you think confidentiality is in terms of system security? It's like what the word confidentiality means. So what do we think of as confidentiality? Stuff that's not publicly seen or known, right? So confidentiality is about revealing information, right? It's very data oriented. If that information is seen, right, heard, known, whatever, by a user who's not supposed to, or a person who's not supposed to have that information, that would be a breach of confidentiality. Okay, so that's a security issue that comes up in the area of confidentiality. Okay. This is oftentimes confidentiality. You have to think of data having value. So this information, if it's valuable, people not supposed to know it. Knowing it would be kind of the theft of value in a way. Okay. Breach of integrity. What do you think integrity regards in terms of information security? And most of this is centered around data. So if I have a piece of data, let's say I have a quarterly report for my company, and it has stuff like how much money was made, how many widgets were sold, that kind of thing. Breach of confidentiality would be, say, somebody outside the company getting that, and it's an internal report that's not supposed to be seen by our competitors or whatever. That would be a breach of confidentiality. What would be a breach of integrity on that type of data? Changing the numbers would probably be a good example of breaching integrity. Okay, because breaching integrity in that case, where you change the values of, say, how much profit we made this quarter. Okay, if you change that value, so even an authorized user accessing that data has the assumption that the data is correct and hasn't been altered by people who are not allowed to alter it. Okay, so looking at that data, trusting that data, they're getting erroneous data, and obviously the data is useless at that point.
So who changed that? From outside source, or
whether it's by accident or an enemy, someone from another company changing it, whether it is an internal employee who wasn't supposed to change that spreadsheet but changed the spreadsheet anyway. Whoever did it, they weren't supposed to. So anybody that's unauthorized to do it, doing that is a violation of integrity. Okay, someone who is authorized to do that, someone from, finance or accounting or whatever, going in and changing stuff, that's not a violation of integrity. That's an authorized change. Anybody outside of that would be a breach of integrity. Okay, and availability. Okay, availability is having access to the data when authorized users want to access it. Okay, availability. A lot of availability violations come in the form of people crashing programs or overloading programs so that they can't service legitimate users, that kind of thing. So the same piece of data, it's hard to make an example with that, but let's say you have a corporate web server, okay, and you're serving up information to the web. That's your advertising and communication with your customers. If somebody comes along and crashes your web server or overloads it so that no other visitors can visit your website, that would be a breach of availability. Yeah, so denial of service is kind of a particular form of availability breaches. Availability comes in forms that are often not termed as, you don't say that this is a denial of service. Denial of service is usually some sort of, exactly that, a service, like a web service or something like that, something, some kind of interactive operation that happens with a user. Another, like an example of a breach of availability that's not the same as a denial of service, or not really called a denial of service, is if I took like that quarterly report and encrypted it and threw away the key. So I made it so that the data is still there. It's still in a form that has the correct information in it. I haven't altered it. I haven't seen it when I'm not supposed to. But I've encrypted it and threw away the key, and no one else can get to it. So that's kind of a, who cares whether it's availability or integrity or anything, because you can't get to it. But that's a different thing that you're lacking than the other examples. Okay? But the theft or denial of service, theft of the service is using a service when you're not supposed to. And denial of service would be making it so no one can use the service. But those are kind of combinations of the C, I, and A. Okay? So, methods of performing these attacks. Masquerading. Masquerading is when you pose as an authorized user so that you can utilize or modify or access these systems or data at the same level that authorized user can. So me logging into a Unix system with your username and password, I now have access to everything that you would have access to. So the breach there is that I'm not you. So I'm not the person that's supposed to be utilizing that user. Okay? And that can lead to all manner of attacks, breaches of confidentiality, integrity, and availability in some degree. Okay? Replay attack or message modification. This is often concerning integrity, or it can lead to some other attacks. But a replay attack or message modification, sometimes one of the methods for preventing attacks is doing something along the lines of having some sort of protocol that goes on between a client and a server, or a user and a service. You might have some kind of magic numbers that you have to send back and forth so it can know that it's you. If in a badly designed system, one might be able to watch that transaction and record those magic numbers and then just play them back to the service so that it can get the same access you did. Okay. Message modification, as an authorized user is sending messages, you can alter them on the way so that they think they sent the correct message, but the server is seeing something else. Okay. More specifically, or a more kind of general case of that is man-in-the-middle. Man-in-the-middle attack is standing between the user and the service, and the user thinks you're the service, and the service thinks you're the user. So you can basically take anything the user gives you, usernames, passwords, secret secret answers to secret questions or whatever. You can take that on one side and then play it back to the server. But then the server, the user is expecting some sort of reply from the server, but you'll get that reply, maybe alter it or maybe not pass it or something along those lines and send it back. Okay? So man in the middle, an example would be me sitting on getting a machine and setting it up between you and your bank. Okay? You go to log into your bank, and a lot of banks these days, they're doing a clever trick where you choose a picture that will be displayed on your bank's website when you're logging in. Yeah, like Bank of America does this, and actually some others do too. You choose a picture that's going to be displayed to you when you're on the banking site. Now, the reasoning behind that is, I give my username or my account ID, and then I don't give my password yet, though. I don't give my PIN. Okay, I give my user ID, and then the bank will display my secret picture, right? The one that I chose. So the idea is that no one could pretend they were the bank site. They couldn't just put up a fake bank site, because when you put in your ID, they won't know what little picture to send to you. Okay? So you get your little picture, then you type in your PIN on that page, then you can log in. Okay? So they've made it so that someone can't pose as the bank and say, I'm the bank. When they come in and give me their user ID, I don't have the right picture to show them, so they know it's not me, so they won't put in their PIN. Okay? So what's the more complex attack? Well, man in the middle. I stand between the bank and the user. The user comes, and what do? They give me the user ID, right? But I need a picture to show them. So I'll take their user ID. I'll take the user ID that they sent me, right, their account number. I'll turn around and I'll go hit the bank's website. And I'll give them the account number. So what will the bank website do? It'll serve up the picture. So what will I do? I'll take the picture, and I'll turn around, and I'll serve it up to the user. What will they do? Oh, it's the bank. I'll type in my PIN. I turn around and send my PIN to the bank. Okay? So I'm playing the client to the server, and I'm playing the server to the client. That's man in the middle.
So that's not secret either.
What's that?
The picture thing is not also secret.
No. Well, I mean, it addresses a particular type of attack, and the type of attack that it addresses is a server is an attacker masquerading as the server. Okay, man in the middle. Usually there are different you kind of rate attacks as to how likely or how dangerous they are by how many capabilities does the attacker need to perform the attack. So the little picture popping up, one of the biggest things that was meant to address is the new style of attacking called phishing. Is everybody heard of phishing? Is anyone familiar with this term? Phishing? Even the non-producers. Anyone heard of this? No? You should.
So they try to bait you, right? I mean, that's the...
Using what? Like an example.
Maybe this might not be right, but sending you an email acting like they're the bank.
That's exactly right. That's the typical phishing attack. Is sending you an email, I'm the bank, and then what happens?
They say, oh, we need to update your account. Please enter your password or go to some site.
Right. So that's usually what happens is go to some site, and then it'll look like the site that it's supposed to be, and then you log in. So, for example, in the bank example, I'm the phisher, right? So I come in and I email you and I say, oh, there's been an account problem. Go to this link that you see there, and it looks like a legitimate link. But when you click it, it actually goes to another site, okay? And it goes to my hacker site, right? That has a Bank of America looking site on it, and it has a username and password blank. But when you type in that username and password, all I do is I say, oh, couldn't log you in, but I'm actually taking all those usernames and passwords and putting them in a database so that I can go and steal all their money from the real Bank of America site. Okay, so that's a typical phishing attack. It's saying, "Oh, I'm the bank. Come fix your money, and then I'll go steal your money." Right? So that's the typical phishing attack. But notice the capabilities, the only capabilities that were necessary. I just need to be able to send you an email, and you need to display a link in a way that makes it look like it's the actual Bank of America's URL, but it's not. And then I set up a little server and put the bad page up. Man in the middle, I actually have to be in between your traffic. I actually need to be able to stop your traffic from getting to the server, and I need to be able to send you traffic and the server traffic. So I need to be able to completely sever the communication between you and the server and be able to do all the operations between you and between the server. So phishing is a lot less sophisticated than man in the middle. Man in the middle is often really the pinnacle of attacking a system. If you have the capability of doing man in the middle, only very strong and complete systems will be able to stop you. Okay, being able to do man in the middle as an attacker, you have all the tricks available in attacking a system. Whereas phishing, you only need a couple little things. And that's what the picture is meant to is attempting to address. The little picture that pops up in your bank is the idea is that if a phisher sends you this email with the fake link to the bank's website, when you click it and you type in your PIN and then get to the next page, you'll say, "Where's my little picture? Where's my, fish or soccer ball or whatever that I chose to be my picture for that site?" And then you can say, "Oh, okay, I'm not going to give my PIN." Who does that? Nobody. But that's the idea behind that technique. Okay? Like if you're Bank of America and they had you choose I think they call it site key, is what they call it, that little picture. That's actually to authenticate the server. That's not to authenticate you. So it's a way of the bank saying, "I am the bank." Okay? So, beware of phishing.
What do they call the ones where the guy from Africa wants you to...
Those are just straight up, those are regular cons. There's nothing technical about those. So, phishing at least is in the realm of doing technical things. But that's the typical sucker born every minute one. This, I mean, if you get caught by a phishing attack, I mean, you're not a complete sucker. Okay. So, and then session hijacking. Session hijacking is kind of a sometimes more advanced or sometimes less advanced than man in the middle. The idea in session hijacking is when the authorized user is using a service or whatever, is you being able to jump right in the middle and take over their session. Okay, so to them it looks like they just dropped their connection, but you've actually continued the connection. This is oftentimes a little bit more complicated in the fact that you kind of got to jump in the middle of like a TCP stream. There's a you have to actually do all of the operations that the protocol needs to communicate while it's happening. So you have to be able to, it's like you have to have a running start where you're watching it, you're watching what's going on, and then you jump in and take over, and then the real user kind of, you just bump them off so that you can take over the session. See, and the thing that's good about doing something like session hijacking is the user's already done all the authentication where they log in with their username, password, all that stuff. So you could jump in there and then have all of their privileges that they have without having to have pesky things like a password, things like that. Okay, so that's this. You know, these two are kind of man in the middle and session hijacking are kind of related in a way, just kind of different styles. What you're trying to do is take advantage of an authorized user giving you the answers you need. Okay? So, okay, and this is, this breaks down what we were talking about, like the capabilities that you need to perform some of these attacks. So the first one, and it breaks the heart that they're not using the typical names of the security people. Typically this is Eve, okay, for eavesdropping. So Eve can watch messages go back and forth. Okay, so the idea here is that the sender and receiver up here, which is usually Alice and Bob. Okay, so you have Alice and Bob talking to each other. Okay, and then Eve is the style of attacker where Eve can watch what's being said between Alice and Bob. So, what are some of the what kind of things could happen there? What do you think is a typical conversation between Alice and Bob? That we'd be concerned with security. Okay, so the data itself. So I'm sending the quarterly report. Okay, I'm the accountant, and I'm sending it to the CEO or whatever. Eve from another competing company comes along and can watch the quarterly report as it's going by, says, oh, okay, I'm watching the quarterly report go by, here's what their profits were, here's how many units they sold. Okay? So that's a type of attack there. Another one might be, Alice might be logging into a server that says, and the server says, login, my username, password, here's my password. So the attacker being able to watch that, they now have a username and password. They can do other things later, like masquerading. Okay? So masquerading, though, okay, is where you have a sender and receiver, or a user and a server, and then you have the attacker posing as one side or the other. So in this case, we're showing an attacker masquerading as the client. So the server will think that that user is the authorized user. Okay? So I go over here, I watch the client log into the server, and I steal the username and password. Then I go down here and I masquerade as that username and password to the server. Okay? What is phishing? Phishing is the other way. Phishing is having the attacker masquerade as the server to the client. Okay? I'm posing as the bank. I'm going to take all your stuff, and then I'm going to pose as you to the bank and withdraw everything. Okay? And then finally we have the strongest attacker, Mallory, but they're not using those terms. But the idea here is that I am stopping the entire communication between the client and server, and I'm posing as the server to the client, client to the server. Okay? Does everybody see how these are three kind of different levels of capability? This is kind of a, almost like a read-only type of attacking capability, which is typically a lot easier to get than other forms of other tools necessary to attack a system. Okay, masquerading. Like I said, like we saw in that example, I gave an example of watching the communication, stealing the username and password, and then posing as the user. So the combination there. You can also have masquerading without any of the eavesdropping happening beforehand. Okay. One way to masquerade as a user is to try and log into that user with every possible password. Right? Just try them all, and then when one hits, you can pretend you're that user. So in that case, we didn't use any of the other tools. And then this one, we have the two difficult aspects of cutting the communication and then being able to kind of simulate the communication. Okay? And this can be the man in the middle can be very difficult, especially if there's a live person over here. Because you have to not only be able to stop communication between that person and the server, and you not only have to be able to create the traffic between that person and the server, but you have to also do it fast enough that they can't tell that you're altering traffic on the way. Okay? So, questions on these attack styles? Okay? A lot of, especially network security, breaks down very simply into these types of scenarios. So it's a good way to think about how they're attacking. Hey, phishing. Okay. So they lay out 4 levels: physical, human, operating system, and network. It's as weak as the weakest chain. It's spelled weak. Okay. But so the weakest link philosophy, that if any of these are broken down, then all of the security is weak. Which is a lot more difficult than it seems to determine which is the weakest link. Okay. So and a lot of these are stronger against some attackers. The same solution to say physical security is strong against some attackers but weak against others. For someone who lives in your neighborhood, a lock on a door is a decent security measure for stopping that person from coming in. For somebody across the country, you don't even need a lock on the door, right? Your security is being far away from them, right? That they're not physically there. Okay, but that person across the country may have all kinds of tools for attacking your network from across the country. Okay, whereas your neighbor who you need the lock on your door for might not even have a computer. So there's, it's not the same group of attackers that you're trying to address with each of these. Okay, but typically attacking a system, you look at all of the defenses they have, and you choose the one that you have the best chance of getting through, right? If you're an attacker, chances are you like to do things the easy way, right? Otherwise, you just go get a job and work instead of attacking people's systems and stealing their stuff, right? So typically, you'll look at all of the different defenses and then choose the weakest one. So a lot of people will invest, hundreds of thousands, if not millions of dollars in their network security, but have lacks physical security. So it is cheaper for an attacker to fly across the country, get to their facility, and then put on a exterminator hat and walk in like they are spraying for bugs, and then go in there, pick up a big stack of hard drives with all the data they want on it, and walk out. Okay, because that's a lot cheaper and easier than trying to go through these $1 million network security systems. Okay, so physical is this, that, usually premises security, the machine you're running on, that kind of thing. Okay, where it actually is. The social engineering, human aspect of it. One way to steal a password is to set up your secret computer that you put on the network to watch all the packets go by and steal the password. The other way is to call them and ask them for their password. Okay, that's the social engineering aspect. And the social engineering aspect, more times than not, is the easiest way into any system. Okay, this includes posing as a system administrator, calling someone up. It's even walking up to a person and saying, "What's your username and password?" and seeing if they'll give it to you. Okay, another kind of social and physical aspect is getting sticky notes that are stuck to monitors that have usernames and passwords on them. Some would consider a human aspect as is guessing a password because it's their dog, their spouse, their whatever, just guessing their birthday. So they also mentioned dumpster diving. I think dumpster diving is just there for the kind of movie effect, but it is something that happens, especially in the days before most information that you find in a dumpster is found on the internet as well. Stealing user manuals and for all the software that they're running there, and to find out all the systems that they're running. Printouts of usernames and passwords, printouts with social security numbers. Anything. So the typical idea is you go to a big corporate facility, jump in their dumpster, and grab all the useful information you can out of it. Okay. And then operating system, and then network. Oftentimes, people do separate host security on a single machine, the operating system security, from the network security. They're very related, though. Okay. There are different techniques on both sides for protecting a network and protecting an operating system. Okay. Program threats. Okay, and this is something that's definitely in the realm of operating system security. Okay, and these techniques are also sometimes used in network. But Trojan horse is a style of attack where the reason it's called a Trojan horse is from the Greek myth of the Trojan horse, where all the bad guys, or good guys if you're Greek, jump into this into the Trojan horse, sneak themselves in. They give it to them as a gift, and they take them in, they jump out, like that, right? So they give you a gift, you take it, and then all the bad stuff happens from there. Okay? Trojan horse is the same idea. It's something posing as something good. It's a program posing as something good, but it's actually attacking your city. Okay? So a Trojan horse, typical one is running a program on a system. Like you go to the lab in Classroom South, okay? You sit down and you log in and you do your work at the workstation. But before you leave the workstation, you run your graphical application that happens to look exactly like the login screen of CS400, okay? Then you leave, okay? Someone else comes in and sits down at that terminal. What will they do? They'll log in with their username and password at the screen that they're familiar with. Okay? Then your program takes their username and password, records it to a file or a database, and then it goes away and logs out, and then the actual screen comes up. So now the user has given a username and password to your program, and it just looks like, oh, I mistyped my password. And now they're sitting at a legitimate screen, they try again, and they log in. So, my Trojan horse was that program that looks like, hey, I'm the inviting login screen, but I'm actually stealing the password. Okay, so that's that style of attack. Questions on that? Okay. Trap doors or back doors. Okay, this is typically this is coded in to a piece of software so that you say, oh, you give a system administrator, here's a nifty server that you can run that will help. I don't know, help do what? That will help help with scheduling your TAs to work in, say, Classroom South. Okay, so this is okay, cool. So I'll run it, and it's a little nifty little program that people can come and see what the schedule for Classroom South is. Okay, but little do they know is that there is a trapdoor or a backdoor where the person who wrote that software can come and hit that site and click somewhere, log in as a certain user, and it will give them access to the system that the service is running on. Okay, so it's a backdoor. It's a way around the normal authentication or even capabilities of that software to get elevated privileges on the system. Okay? So, logic bomb. Logic bomb is the type of malicious program that doesn't just when you run it, it does something bad. These are usually a lot harder to find because it'll need a bunch of circumstances before it triggers. So you don't know when you could have started the program running or the virus running months ago and not even realize it. And it's sitting there waiting for a particular date to come up so that it can pop up on screens on all the computers that have it. It's waiting for a combination of events to come up, like certain users logged in at a certain time, that kind of thing. It's waiting for you to open a document called, thesis.doc or something before it erases everything. So there's some more complex set of conditions that trigger its activity. Okay, and stack and buffer overflow. These overflows are ways of exploiting a program, a badly written program, to escalate your privileges. A quick example of this. Okay. First of all, when a program is running, okay, it's running usually in what's called a context. It's running as a particular user, and that user on a system typically has specific privileges. Okay, so let's say I have a service that runs on a system that it's a network service. What's a simple example? It's a little web server. Okay, we have a little piece of web server software, and we run that little piece of web server software as the system administrator, as root on Unix. Okay, so we're running this as that user. That user has complete access to the system, right? So I will be running on a server, okay, and I'm listening on port 80, okay, with that program. This is my web server, okay, and that's running on, on top of the operating system. Okay, the operating system sees the web server as the system administrator because that's who's running it. Okay. If I can send a particular message to this web server that exploits a bug in the program, okay, which can make it so that, what if I can make it so that that web server software can execute any instruction that I want, like, for example, exec. Does anybody remember what exec, E-X-E-C, what exec is? It could run another program. So you'd say something like exec, run a shell for me, for example. Okay? So if I could get the web server to execute the command exec bin shell, what would that mean?
Taken over the operating system and do it.
Okay. Specifically, what does that mean? We know something bad's going to happen. I wouldn't be talking about if something bad's going to happen. What do you mean by taking over the operating system?
And run anything it sends or already sent to.
How and why?
Because when it set up the exe problem at the same time, then a packet is already sent to them. So,
No, what I'm saying is why would we be able to run whatever we want with that bin shell? From the operating system standpoint, this being executed, the exec being executed by this process, what does that look like to the operating system? It looks like running shell, right? Running the shell program, right? Which is your interactive command line, right? Who's running it? To the operating system, who is running the shell? What user is running this shell?
Whoever started this block here.
Started what block? Whoever started the web server. Okay, so whoever started the web server, if we get the web server to execute the command exec bin shell, it'll look like whoever started the web server is running the shell. Who did I say started the web server before? The only user that counts, root, right? I said the system administrator ran the web server, but this other attacker got the web server to run exec shell. So now on the operating system, we have a shell running under the control of the attacker, but the operating system thinks they are root. Okay? So if that user runs other programs, they're running it as root. If they want to delete files, which files can they delete? The ones that root can delete. What programs can they run? The ones that root can run. Okay? So, for an attacker, that would be awesome if we can run this command using the web server. So how do we do that? We do that with stack and buffer overflows, okay? Buffer overflows. I'm going to give you a very, very quick rundown of a stack overflow. Stack and buffer overflow, okay? So, to understand overflows, you need to kind of think in a lot of detail of how a program looks in memory when it's running and what happens in memory when it's running. Okay? So, we've already run into what kinds of things the stack does. Okay? Does anybody remember how the stack is typically used in a running program? What's the other thing besides the stack? What was the other thing besides the stack that we often talk about in relation to the stack? The heap. So there's the heap and the stack. How is the stack used?
Variables.
First in, last out.
That's the heap. What's that?
Like operation, like first in, last out, or
No, I mean that's how a stack works. But the stack, right? In a program running, how do we use it? It is a stack though, just like what you're talking about. First in, first out. But where were we using stacks? Function calls. When I call a function, what am I putting on the stack? Well, the thing I'm running right now. I kind of push that down there so I can start running a new function. I get done running the function, I can pop the stack, right? Or I can call another function and push this one on the stack. Okay? So, that's important. Let's say at the bottom of this, I'm storing some data. And then I'll go ahead and put a stack up here at the top. Okay? So, right now, I'm running along in my main function, my main part of my program. Okay? So then I go and I call a function. So what will I do? Well, if I have a program and I'm running through some of the instructions, and then I call F1, my function, right? What do I need to keep track of before I go and jump to another set of instructions for function 1? In other words, when I get done with function 1, what will I want to do after that? Come back here and keep running the lines of code after this, right? So, what do you think I need to get back to there? I will need a program counter, an instruction pointer. But where? What should the value of that instruction? After the function, right? So I need to know where to come back to. So I need a return pointer of some sort. Okay? So I need to push into the stack, I need to have the return pointer coming back. Okay? And then also typically in functions, I want to store local variables as well because they're going out of context. And I need another context to have different. So you'll have that and other variables sitting in the stack. You'll take all of that stuff, like the return instruction stuff and the other local variables. You push them into the stack, go call F1, and run that stuff. And then that might call another function, and you'll do the same thing. Okay? A stack and buffer overflow, the typical idea is getting a set of address, an instruction to write to an address to overflow where it's supposed to write until we can write over the return address in the stack. Okay, so one second. So why would you want to do that? Well, if you can put any number you want in the stack as the return, okay, what that means is that when this function call gets done, the CPU will want to return to where it was running before. So how does it know how to return? All it can do is load the instruction pointer from the stack and put it in and jump to that instruction. Okay? In a working system, that instruction pointer will have the instruction right after the function that we call. But it can be any address, and the CPU will jump to that address and start executing code. Okay? So, what would be a good thing to do? Well, what you do is inside the data segment of your program, okay, the attacker will fill that up with bad stuff. Okay? So what I'll put into the data segment is the machine code for executing a shell. Okay? And then I will get the address of those instructions, and I will try and directly write it into the stack. and then I'll wait for that function call to be done, and when the CPU comes back to load the instruction pointer, what will it load? It will load the address of the code I want it to execute. It'll jump to that instruction, begin executing, and it'll run our bad code. How do we do this? Well, typically it's through overflowing buffers. If you do something like in C, what is the statement? The statement here, the char buffer 10. Of how many? 10 characters. Right? So the idea is that I want 10 memory spots, 1 byte each. Okay. What's here beyond it? Not nothing. It's memory, right? It's memory that we're not supposed to have. Okay. Is the statement below there? I mean, this next statement, is that legitimate in C? It's actually a legitimate statement in almost any language. It's a matter of whether or not it will be executed.
It's a out of bounds exception, right?
In Java. Right. In C and C++, what will happen? It will work. You will write an A to that memory location. You have overflowed your buffer. You've gone beyond the end of the buffer you were supposed to have. So you write your bad stuff.
So the bad stuff goes in the buffer, or?
Well, typically you'll put it in data somewhere. It's not as important that you get beyond the buffer to put your bad stuff in, because you can put that in any variable you want. The real important thing is that you can overflow to get to it's the stack to the instruction pointer, and then you write a number in there.
So how whoever putting it on, how he knows that exactly that after the function called the pointer number or whatever index is given, exactly what specific program or something. How is that?
He's smart. I'm serious. I mean, how does he know? Is by knowing how programs are laid out. How does the computer know?
This is generated at that point. When the stuff
By doing what? By adding things together, by starting at particular memory locations and working your way back. If a computer can do it, a person can do it. And all it is changing numbers to different values. That's all it is. Okay? It's thinking about programs beyond the high-level programming that we do. Okay, how do they know? Well, they study architecture, they study memory layouts of what how operating systems lay out memory. They study compilers to see what exact machine code that those compilers spit out. If I can draw it on the board like that, where I put a number up here or change a number there, you should be able to write a program that can do that. I'm not saying you should be able, I'm saying one should be able to write a program that can do that. Okay? And that's the thing that you really need. If any of you kind of want to do things with security, the thing you need to understand is that attackers are awesome programmers.
That's the worst.
Okay, and that's the thing is if you want to battle them,
They're very talented. But
you need to be awesome programmers as well. Okay, I mean you really need to study what actually goes on inside a program because the idea is in computer science we learn about programming and computers the way they're supposed to be used. Okay. When you really get into it, you should also be learning how computers and programming is not meant to be used, because then you start seeing the shortcomings and where stuff can go wrong. In other words, we're just as happy having the stack build up just through normal function calls and stuff like that. But if you want to get into this kind of thing, you need to really ask yourself, well, what would happen if I altered this in the stack or jumped directly there and overrode a memory location and stuff. Because when it gets all said and done, all the fancy stack and heap and function calls and stuff like that, that's all conveniences for programmers. But when it's all said and done, it is all machine code. Okay? Questions on that? You don't have to know the details of that. Those are the strongest types of attacks. Because you can get it to execute arbitrary code as any user that's running a program or running the program that has an error. But also keep in mind, this is from an error. Okay, this is exploiting an error in a program. A good program will not have this instruction in it where you go beyond the end of a buffer. Okay, a good program will check the bounds of buffers that you want to write to. Okay, because typically the statement will not look like buffer 15. Okay, typically there'll be a variable inside there, and that variable will come from user input. Okay, that kind of thing you just can't do. Okay, so that's an error in the program, trusting user input to give you a value that's within the bounds of the buffer. Okay, so all of this is from a bug, but it is very powerful in what the attacker is capable of doing from there. Okay, and then also, are there operating system and hardware things that we can do to help prevent this? And I mean, most people argue that the fact that we still have stack and buffer overflows is absolutely ridiculous. Okay, a lot of people feel that our programming tools and our operating system tools and our hardware tools should prevent this from happening, because you should not be able to write to those values in the stack as a user. Okay, you should not be able to, load executable code into the data segment of your program. Okay. Oh, look at those. They have a little. Oh, it's hard to read, but they have a little example here where they keep copying stuff into a buffer. And the main reason here is, I don't know, it's hard to read, but can you kind of see it? Kind of see it? The problem is this string copy is taking what's called this is an argument that comes into the program from the command line. Okay, this is actually the first string after the program on the command line. The idea is that if you make this string larger than the buffer size, you will overflow this buffer. In other words, start writing beyond the end of the buffer. The reason being is C doesn't do bounds checking on that string copy call.
What does that be inside what's that? Is that numbers?
Yeah, 1. It's getting the first parameter after the program. Okay, but put this on, qubit and run it. It'll work. Okay. Oh, there we go. Here's a stack frame, return address, and variables and stuff and parameters. And then here's exec. Okay. What else do we got? Here's a virus, a Visual Basic macro that will reformat the hard drive. Don't try this in Visual Basic. But it's just, all it is a script that runs the internal format command. Okay, but typically, what they're saying is a virus is a code fragment embedded in a legitimate program. Typically, viruses also reproduce themselves. In other words, they get the program that's executing them to create new copies of them. Okay. Let's see what else we got here. That's interesting. System and networks threats. Worms. Worms are typically network oriented. Okay, they happen on networks, utilizing often exploits inside operating systems. Okay, one of the and worms typically will replicate themselves as well. So the idea behind a worm is the worm starts by it's some code that runs that exploits problems or typical problems found in an operating system. Okay. One of the most famous original worms was one that exploited some programs on Unix, Finger and Sedmail. Finger was, anybody familiar with the program Finger? Finger lets you touch somebody on a remote system and find out what they're doing. So the idea is that people working on these Unix systems, you'd write a little file called a plan file that would say, I'm working on a new text editor, and I'm going on vacation next week. Okay, so you'd put that in your plan file, and then somebody could finger your account, and it would say, oh, user so-and-so is working on a text editor and is going on vacation next week. Okay, so that's what Finger did. But there was a bug in Finger that let it do bad stuff, like run additional code. So what this worm did was it went and it exploited these exploits in Finger and in Sendmail. It said, make new copies of me. And then once you make new copies of me, what I want you to do is I want you to go through the known other hosts that this system knows about, and I want you to go see if they have Finger and Sendmail. And then we're going to exploit their Finger and Sendmail and have them replicate me, and then go through their host file and look at all the hosts they know and replicate and look for Finger and Sendmail. So the idea behind the worm was you use an exploit to execute your code, but what you put as your code is replicate yourself, then go look for other systems that have the same exploit and then continue. So that's a worm. Okay. Typically they'll take advantage of something called port scanning. Any idea what port scanning is? Okay. Typically, when a network service runs, it'll run on a well-known port. Okay. What that means is if I want to send you email to your system, I will talk to port 25. Okay. So if I'm another system on the network and I want to talk to your email server, well, I can find out where your email server is by its address, but it probably has a bunch of things running on that email server, right? It might not just be the email service that's running. At the very least, you probably have telnet or other ways to connect to it. So how do I pick out the email server from the other programs that are running on that computer? The port number. So I would go to a port like 25. Well, a very simple way to find out what servers or services are probably running on a machine is try to connect to every port on it. Okay? And if I try to connect to every port on it, if I get a response, in other words, a connection to, say, port 25, I can be reasonably sure that your system is running a mail server. If I get a connection on port 80, I can be pretty sure that you're running a web server. 21, FTP, 23, I could be sure you're running Telnet, 22, SSH. Okay? So that's the typical way that you find out what's running on a system. Well, why would I want to do that? So I can see if you're running finger and sed mail so my worm can, exploit them and whatnot. Okay? So port scanning is looking through, trying to connect to all the ports to find out what programs are running on a system. Okay? And then, when it's all said and done, what happens when we have too many copies of this worm going around and replicating themselves and port scanning other systems and doing it again and again and again, is everything gets overloaded and doesn't work anymore. That's considered denial of service. And there are multiple ways to deny service on a system. Okay? The latest, greatest style of denial of service is distributed denial of service. Distributed denial of service typically uses what they call zombies. Okay, you take over other people's machines and then use those machines to do denial of service on another system. Okay, there's a problem that comes up when trying to deny service. R. Okay? That's the bad guy. R. Okay? And then here is someone gets really mad at the CS department for operating system classes running too long. Okay? So they go, I'll show that computer science department. Right? I'm going to make their web server so that nobody can hit their web server. Leave hacks over it. Okay, so I'm gonna attack the computer science department web server. Unfortunately, I'm only mad because I'm a horrible student. I don't know enough about the programs that are running or whatever. I don't have any exploits I can take advantage of that would make it so I can crash the web server. So my only option is I need to hit the web server with enough web traffic that it can't serve anybody else. I'm going to deny service to anybody. So, I'm in my mom's basement and I'm, attacking the computer science website. What's the problem here if I want to generate enough traffic that nobody else can be serviced by the web server? Why not? Because yeah, my mom just got cable, so it's cool. So I got a cable modem, right? So I got like 1 megabit. Okay. Meanwhile, the University System of Georgia was gracious enough to, have T3 type level bandwidth coming in. Okay, so we have tons of bandwidth coming in here. So I can't take my little cable modem pipe and generate traffic to fill up this big pipe coming into the website, into the computer science web server. So what do? Well, what I do first is I go find myself a script or a virus or something that can take over all these little, users who just got DSL but don't have any personal firewall or anything like that on their home computers. I take over their computers, and what I try to do is I get their little cable modems to send traffic as well, and I get enough of those that I can overwhelm the T3. Okay, so the idea is you infect these computers with a virus or something, they become what are called zombies. Okay? And then you have a remote control program for the zombies that you hit a button and they all start hitting the computer science web server at once. Questions? So this is looking at the technique that the Morris internet worm used. The Morris internet worm was kind of the first worm. It was when the internet was very young, and this was kind of they saw this guy Morris saw in a what's it called an error in finger and send mail that he could use to make it replicate itself. So he kind of did it as an experiment to have it replicate itself and then look for other machines and have it replicate itself. And then it got out of hand and it basically crushed the early internet that was there before. And this typically would be a lot harder to do today just because the internet's so big compared to what it was. Okay, but notice what they do is they bootstrap it by running, by getting the worm started, and then it will use, it uses the finger and send mail attack to put in what they're calling a grappling hook. I've never heard this term in relation to worms, but they'll put in the code to make it spawn another copy of the worm. So it'll say, okay, I am now running on the target system. I am going to request a copy of the worm from the original worm that's sent to me, and I'll copy it onto the system and run it. Well, now that that's running, you'll see that you're back at the beginning of the loop, where now you can go find another target system with this combination of attacks, install your hook, and then bring the copy along. Okay? So, next up, just some brief things on cryptography. Okay? Cryptography, and this is a good point that they have here, is one of the broadest security tools available. Cryptography can address many, many security issues. Okay? The typical, what do you think of when the term cryptography comes up? Encryption. What is that for? What is encryption for?
Middleman
What's that?
middleman or can access the data.
Get more big. Don't try and fit it into those things because it can actually fit into all of them. Just in general, what do you think of encryption being?
Like,
how do you understand it to work? How do you understand encryption?
you put a lock on some data, you change it so that nobody can read it unless they have a key.
Okay, so what is this lock? You're making it so they can't read it, right? So what are you doing to the data? Okay, so you change it so it looks like gibberish, and that's exactly what that's what you do with cryptography with encryption. You take data that you can read that's not gibberish, right? And you shuffle it around until it is gibberish. But the trick is that you can unshuffle it out of gibberish back into legitimate data. Okay? But the thing you need to make sure of is that the only way to unshuffle it is with a key. Okay, so that's how it's a lock and key. It's that you can shuffle it up. It's not, you can't read it, but using only the key, only if you have the key can you unshuffle it back to legible data. So that's the most basic form of cryptography of encryption that we typically use. Okay, but actually encryption and cryptography is useful for all manner of other things outside of that. So that technique of encrypting data using a key and unlocking it using the same key, which aspect of security does that help with? What aspects of security am I talking about? How many of them are there? What are the big ones? Confidentiality, integrity, and availability. Those are the three big ones. So which of those are we addressing with something like encrypting data with a key? Confidentiality, first one. Right? Because if we can make it gibberish to everyone except for people with the key, what do? We just give people who are allowed to read it the key. And then now, right, if anybody else gets that data, it doesn't matter. Okay? That's the typical when someone says encryption, that's typically what people think. But there's tons of other mechanisms in cryptography that can actually address not only that issue, but other issues as well, using different, different techniques. So, broadest security tool. I agree that broadest security tool available. Some security courses are exclusively talk about cryptography and nothing else. Okay, is that you can actually cover most of security ground, both in operating systems and outside of operating systems, just by talking about cryptography. Okay. Based on secrets, keys. Okay. Real quickly through. Oh, this diagram doesn't show up very well. Okay. I just want to get through the typical encryption real quick, and then we'll be done. Okay. You have a message. You send it through your black box, which is an encryption algorithm. You add in a key. Out comes your cipher. What are they saying? Yeah, okay. That's encrypting, okay? I take a message, I send it through my algorithm, add in a key, get a cipher. So, what do you think the other side of this communication looks like? I'm the accountant. I take the quarterly report and a key, pop it in, and then I get this. And I give this to, like, the CEO. So what does the CEO do? So what does the CEO have now? He has the cipher. Right? What else do we need? We need a key. We also need the key. Then what else do we need? So what do we need to do that?
So what is the cipher? Is the message?
The cipher is the jumbled message. What am I missing? Yeah, so the decryption of it. And what will come out? Read the message. Okay. Now, what is secret here? The key. Right? Does it matter if an attacker has the AES out, or the encryption algorithm? Any other answers?
They know how it's encrypted.
Yeah. Right? That's right. You should not mind that an attacker has the encryption algorithm. Okay? And that, in fact, that is the basis behind judging an algorithm. Is the key the only way to decrypt a message? Okay? Do we mind if the attacker has the ciphertext? No, in the same way that if the algorithm is good, You need the key to turn that into anything useful. Okay? So, what we've done is we've reduced it down to this being secret, and this is still secret, right? But the message itself is still secret, but we've made it so that we have a way of transporting it. We transport it using the cipher. But, here's my question to you. Have we solved our confidentiality problem? Have we solved it with our technique?
We just complicated it more by adding the key.
Why is it more complicated? I'd argue that you've simplified it.
Well, instead of just having the message, now you have the key, the jumbled message, and the encryption algorithm.
But do we need to worry about the encryption algorithm or the jumbled message? No. But you have a good point, and that is what? The problem now is not transporting the message. What is the problem? Transporting the key. That's not the hard part. The hard part is both sides need to be the only ones that know the key. It's real easy to have somebody else know a key. You can just post it on your website. Okay? The hard part is, are those two people the only ones that know the key? Okay? What I'm saying is you're not as concerned with your partner having the key. You're concerned with no one else having it. Okay? So, but you have changed the nature of the problem, and the main thing is that now the problem is getting the key to the other side. Okay? But you have increased the flexibility because now you can change the message whenever you want and still have the same key. Whereas before you didn't have that option, right? If I wanted to change the message, I'd have to resend the whole message. But now, if I can get the key to the other person and you're the only ones who know, now we can send any message, right? Instead of having the original problem of transporting the messages. Okay? But that's something very, very important to think about with encryption. Is the main thing is that you want to distill the secrecy down into something like a key. Okay? The reason being is that now we have very good control over what we do with that particular key. And the other thing is that we can change the key if we need to, if it gets released or something like that. Okay? Okay? This type of technique that we're seeing here in this in the diagram is known as symmetric encryption. Okay? It's called symmetric encryption because the same key that you use to encrypt is used to decrypt. So in other words, you share a key to encrypt and decrypt. Okay? This, again, is the textbook, like what I think of as encryption when you say encryption technique. Okay? Symmetric. Okay? There are additional techniques that are different than this. Any guess as to what the other technique is? Asymmetric, right? Anytime you see symmetric or synchronous, you think asynchronous or asymmetric, okay? So, symmetric encryption is, your standard share a key and then use the key to encrypt, decrypt. If this were a few years ago, we'd be talking about DES, okay? Digital encryption standard. Not used anymore, hopefully, okay? At the minimum, people are using triple DES, okay? What do you think triple DES is? What's that? But how do you think it's implemented? What's that?
Saying they're considered more secure. This is probably higher level of it.
How would you design triple DES?
The 3 levels of encryption.
What are the 3 levels?
3 keys.
Yeah, that's the key. 3 keys. Okay. Just the naive way of doing it is you take the message and you take key 1, send DES through it, and you get cipher 1. Then you take cipher 1, key 2, send it through, and you get cipher 2. Right? Take that, key 3, send it through, you get cipher 3. And then that's what you send. What does the other person do? They take cipher 3, key 3, decrypt, decrypt, get that. Okay? But you actually do it a little bit differently. You do encrypt, decrypt, encrypt with it, and it's really complicated why you do that rather than just encrypt 3 times. But if any of you are interested, it's called a meet in the middle attack if you don't do encrypt, decrypt. But now we use advanced encryption standard 2-fish. I don't think that's true. But, oh, they're saying 2 different algorithms here. Okay, AES, within the last few years there was, or actually it's probably longer than that, AES was recently standardized, which is, they had a contest of people making algorithms and then they picked the best one. But the one that won AES was known as Raindoll, and I have no idea how that's spelled, but that one won. 2-fish was a runner-up. And those are known as block ciphers. And there's another type of encryption called stream ciphers. But and that's it. That's all we're going to talk about today. I will probably touch a little bit on asymmetric and authentication next time.